This video is for Unit 3, Lesson 1, Part 2, which will continue our study in factoring. Remember, we're going to be parked in Lesson 1 for several class periods while we cover all the bases with our basic factoring. So a quick recap of the last lesson. I want to try my best to tie the different lessons together so that we are all on the same page. So what in essence are we trying to do? We are trying to do this thing called factoring, okay? And what that means is finding what multiplies to give us an expression. Okay, so that's what we are trying to do. Now, why we're trying to do it, we haven't covered that yet. That's going to have to do with actually solving the equations. Okay, so factoring would be one step in a bigger process. So that's what we're trying to do. We are trying to factor. What is factoring? That is finding what multiplies to give us a specific expression. So for examples, you can see like kind of an illustration. If somebody were to say x squared minus 2x minus 15, okay, you would be asked what two things multiplied would give you x squared minus 2x minus 15. And the answer to that would be x minus 5 and x plus 3. Those are the two factors. Okay, so x minus 5 would be one of the factors and x plus 3 would be the other factor. Now you might be wondering, well, how did she do that? How did she know that? Well, I've factored a lot. Okay, and in a perfect world, you would be able to do that as well. You would be able to look at x squared minus 2x minus 15, and you would just be able to see, oh, that's going to be x minus 5 and x plus 3. But it takes a while to get there. I have been doing factoring. I have been teaching factoring longer than you've been alive. So it's been a long time. It takes lots of practice. Now, the model that we're using to visualize or lay out our factoring is something called an area model. And how factoring relates to the area model is like this, okay? The area is the x squared minus 2x minus 15. So you are given the area, and that x squared minus 2x minus 15 is broken up between these different rectangles, and we find the area each one. And the factors would be the x minus 5 and the x plus 3. Okay, and so x minus 5 times x plus 3, the base times the height, would give us the area. And it's just one of many ways that you can lay out your work on the page to try to visualize what's happening. If you prefer other methods, that's totally fine. Just know that when I am teaching the lessons, when I'm reviewing, when I'm answering student questions, I am going to be using the area model in class to make that clear. So that is what we are trying to do, and the method that we're using to do it is this called the area model right there. So in this particular class, there is a warm-up. So if you're watching this, if you were in class and you're watching this for review, then you should have this in your notes, and we'll just go over it again. If you were not in class, then this is what you missed for the warm-up. So in the warm-up, I gave you 4 problems. 2 of them go one direction, and then 2 of them reverse the direction. So for numbers 1 and 2, it says to distribute. Now you should know distribution from Algebra 1, so I am not going to go back and review what distribution is. If you need to review it, okay, I need you to do a couple of things. I need you to either come for tutoring on a Monday and come specifically saying, I need to review what distribution is because I did not follow that in class, or I need to review the second part of that. Or you, if you can't stay after for tutoring, I need you to send me an email or post on Teams, tag me in your post, okay, so that I know that it's there. It'll send me a little notification. And then specifically say when you did the warm-up on distribution and undistributing, which is factoring out a GCF, is the the way we would normally talk about it. I need more review or more practice. Can we meet on Teams, or can you record a special video just for that? I actually think I have some videos on that from that summer assignment in the Algebra 1. So hopefully if you did the summer assignment, you watched the videos, you are okay with this process. So the first question here is distributing. We have 2 times x plus 3. Well, distributing is this. It's the multiplication of something through or over addition or subtraction. The arrows are not the distribution. So you can draw arrows forever and not distribute. And you can certainly distribute without drawing the arrows. The arrows are simply there because teachers will use that so that students can follow what we're doing. It just helps your eyes track. So we're going to do 2 times x, and then we do 2 times 3. Well, 2 times x is 2x, and 2 times 3 is 6. Okay? Sometimes we will actually write it out this way. We'll write it out with the prime factorization. So we'll do like 2 times x, and then we'll do 2 times 3. And what that does is it allows you to see the multiplication by the 2. Okay, and then we would go to the 2x plus 6. Usually, most of us are going to skip over that step. However, if you end up struggling with the factoring end of this, okay, and you're like, okay, I followed 1 and 2, but I can't do 3 and 4, one of the ways that I would go back and explain 3 and 4 to you is going to involve this step right here. Okay. So it is worth taking a look at. For the second one, we have -4, and we're going to distribute that over x squared minus 2x plus 3. So again, you don't need to write any arrows. Okay, sometimes I'll see students that write the arrows and then they don't do the distribution. So we're going to take the -4 and multiply it through the parentheses. So we'll have -4 times x squared, which gives us -4x squared, and then -4 times -2x. Okay, so this would be a negative times a negative, which is going to give us a positive, and then 2 times 4 is 8, so that'll give us 8x. And then -4 times 3, which is -12. You could write plus -12. Most of you would be comfortable writing -12. So that is your, what we call the forward direction. That is your distribution. If you want to put some arrows in, you can. All right, you're welcome to do that. Not required. Okay, that's distribution. Now for 3 and 4, the directions say factor. Remember what factoring is. Factor means finding what got multiplied to give you the expression that you have. So if you look closely at these first two, okay, if you were given 2x plus 6 and you were asked to factor it, that question would be asking what got multiplied to give you the 2x plus 6. Well, the answer would be 2 times x plus 3. So the factors are 2 and x plus 3. So what we're going to do in the second part here is undistribute. Now, undistributing is not really a word, okay? It kind of gives you the idea of your going backwards from the distribution. The correct word is factor, and what you're looking for is what's called a common factor. So in number 3, we have 2x squared plus 2x minus 10. So the question there is, what was it that got distributed in there? Now, hopefully you're looking at that and seeing like the 2. Now, what might help you, though, is to do that little middle step. And I'm going to take the 10 and factor that into 2 times 5. And when I do that, it makes it a little bit easier to see that the number that got multiplied through was a 2. Just like in this step up here, okay, sometimes it's a little bit easier to see it if you can see the multiplication done out. So we are going to take that 2 and we're going to undistribute it. And so if I have x squared and I factor out the 2, or 2x squared and I factor out the 2, I'm left with an x squared. If I have a 2x and I factor out the 2, I'm just left with an x. And if you have 10 and you factor out a 2, you are left with a 5. So it's a little bit easier to see when you look at it this way. If you have a 10, well, 10 is 2 times 5, and we're going to factor the 2 out, which is going to leave us with the 5. Now, some of you might be saying, oh, well, you could just do 10 divided by 2. Yes, you actually can do 10 divided by 2. Somebody in one of my classes today, actually, so today's an 8A that I'm recording this, noticed that in the rectangles, they noticed that you could get the other number by doing division. And I said, oh, hang on to that. You're onto something there. Okay, so that's how you would do the factoring. And then let's look at the last one. The last one is negative 3x squared minus 12x plus 3. There are two things you might factor out of this. You might factor out a negative 3, or you might factor out a positive 3. In order, both of them would be correct, okay? But what might make it a little bit easier to maybe figure out what you should do is when you finish with the factoring, you want this to be positive. So you don't really want to have a negative still stuck on the inside. So if you see a negative, you kind of want to factor it out. Now, I'll do that middle step again so you guys can see it. Oh, I want that blue one. There we go. So we have negative 3x squared minus, and then I'm going to do 3 times 4. Okay. And then this might be helpful to think of that as 3 times 1. Okay. We don't usually bother to do that 3 times 1 business, but when you factor the 3 out, you can't be left with nothing there, because then you don't have anything that you could distribute back into. So we're going to take that negative 3 and bring it out. And if I have a negative 3x squared and I take the negative 3 out, I will be left with x squared. If I have negative 3 times 4x and I take the negative 3 out, I'm going to be left with a positive 4x. And then this last one, we want to be really tricky. We're going to take out the negative 3. Okay, we're going to take the negative 3. My phone keeps registering that I'm saying stuff. It thinks I'm asking a question, which I'm not. So when we go to take the negative 3 out, we're actually going to be left with a negative 1. So how can you check to see if you did that correctly? Because that's a little bit dicey there. You could try to distribute. So negative 3 times x squared would give you the negative 3x squared. Negative 3 distributed to the 4x, well, negative 3 times positive 4 is negative 12. So negative 3 times 4x is negative 12x. And negative 3 times negative 1 will give you positive 3. Okay, so you can kind of see that's a spot where you might make a mistake. Now, down at the bottom, it says, if you want to check your answer, try graphing the problem and your answer and see if they're the same graph. So if you wanted to, you could take, go over to Desmos and type in negative 3x squared minus 12x plus 3. And then in a different line, type in negative 3 parentheses x squared plus 4x minus 1 close parentheses. If you get the same graph, then you know you did it correctly. Okay. If you get different graphs, then you know you made a mistake somewhere and you can go try to find it. All right. So that is the warm up. So that took me about 10 minutes to go over the warm up. I guess that's not too bad. That's about 2.5 minutes per problem, making sure that we're explaining that process. Go back and watch it again, or take your time to fill that in if you need to. So why do we need to factor out any GCF? If you're wondering, what does GCF mean? GCF stands for greatest common factor. And hopefully that makes a little more sense to you now that we've really talked about what factors are. Factors are things that are multiplied. So the greatest common factor is the biggest thing that is multiplied into many different things. So the biggest one that they have in common. First reason why we need to be able to do that step from 3 and 4 is that it needs to be listed as its own factor in the final answer. Okay, so when you're factoring out, if there's a GCF, it needs to be listed separately as a separate thing that is multiplied in. It also makes our numbers smaller for the area model. All right, so when you can take that greatest common factor out and you bring it out to the outside where it is its own thing, then whatever's left over is going to be smaller, and that's going to make your area model easier to deal with. So that's why we need to factor out the GCF. We always look for a GCF when factoring. Okay, we look for that first. There is not always a GCF, but we always look for one. Okay, so if there is one, we need to get it out first. So how can we figure out the small rectangles when starting from scratch? Excellent question. I am glad you asked. Okay. So how can you figure out those small ones? Now, the last homework problem, which I am going to delay going over, it's going to come up on a slide in a little bit, is has to deal with that because you were just given the blank rectangles. You didn't have anything filled in. So I'm glad you asked. How can we fill them all out? Well, your x squared term is going to go in the upper left. So whatever your x squared term is, that goes in the upper left because it comes from the factoring of the two x's, or the multiplying of the two x's. The constant term goes in the lower right. And that's because if you have something like 2x plus 3 and x plus 4, 3 times 4 is going to give you a constant term. It's always going to be in the lower right. And if you have an x times another x, it's going to give you the x term. The tricky part is figuring out what goes in these two boxes. Those two boxes need to add up to the x term, because when you add up all the boxes for the area, okay, these two are going to be the two that combine, and we've seen that before. You have like x squared, and then you have 2 plus 14x, and they add up to 16x, and so forth. In here, those two need to add up, and so that's how you need to break them out. Here is what you are looking for. You are looking for two numbers that will multiply to give us the constant term, but will add to give us the x term. Now that probably sounds a little bit familiar, but I'll give you a little bit of an example off to the side here. I'm not totally sure. I would recommend that you write this down, okay? But let's say you have a 2 and a 4, okay? The 2 and the 4 are going to multiply to give you 8. And then let's just say there's an x and an x. You're going to end up with 2x and 4x. The 2x and the 4x need to add up to give you, like in this case, it would be 6x. So whatever you put on that diagonal, they are going to need to add to give you whatever your x term is, also called the linear term, and they're going to need to multiply to be able to give you what's in that lower corner. That is going to be your key. You're going to start with, okay, what are the things that could multiply to give me that constant term? What are all those things that could multiply to give me that constant term? And then of those possibilities, which ones add up to give me that middle term or that x term? So we're going to look at that last homework problem, okay? This is one that's in your last homework problem. So if you haven't submitted it yet, or you haven't finished it, you can actually kind of follow along, go back into Desmos and finish this one up. In class, what I'm going to tell people to do is open up your Desmos and go to that last problem, and let's make sure you have that last problem done right. So we know from experience that the x squared is going to go in the upper left, and in this case, negative 56 goes in the lower right. And actually, coming out of the last class, there were several people that had that, and they're like, okay, now what? Now you have to figure out what combination of x's, okay, so these are going to both be x terms, what combination of x's is going to work out right here. So the hint that I gave people was look at the 56. Look at the 56, because whatever numbers we put in there are going to come from the 56. So in the first lesson, I said, what are the factors of 12? What are the pairs of numbers that multiply to give you 12? And all my classes said 2 times 6, 3 times 4, 1 times 12. We need to do the same thing with that 56. We need to find all the combinations of numbers that multiply to give you 56. Now, 56 is a bigger number. The bigger the number that you're dealing with, the harder this is going to be. And when we start dealing with having a number in front of the x squared, it's going to get even bigger. So you want to have a plan for doing it. You do not want to just start shouting out like, oh, well, 2 times 28 and 4 times, I don't know what it would be off the top of my head, but we're going to find it out. Okay, I'm going to show you exactly what I would do. Now, I happen to know what the numbers are because I do know my times tables, and most of the time it's going to be something from your times tables, but I know a lot of you are kind of shaky on your times tables. So what we're going to do is just start with a method. So we always know that 1 times a number will give us the number. Now, there is no way that I can put over here 1x and 56x and possibly get negative 1x. Okay, which is what I want. I need these to add up to the negative 1. Not going to be a 1 and 56, but we're going to start there. 56 is an even number. So I know that 2 will work, and if I'm not sure, I'm going to grab my calculator. Okay, I don't know about it. It's not, I've got the blur function on, but it's obvious I'm in my classroom. Okay, and I'm just going to grab this, and I'm going to, on my calculator, do 56 divided by 2, and it's going to tell me 28. You'll just have to take my word for it that it tells me 28. Now, there is no way that I can put 2 and 28 in here to get negative 1x. So that's not right either. Now, I don't know if 3 works. Now, there's a trick you can use. I can tell you what the trick is. I know that 3 isn't going to work, but let's just say hypothetically I don't know. I would, on my calculator, do 56 divided by 3, and I get some kind of decimal. Okay, so 3 doesn't work. I do know that 4 is going to work, and the way I know 4 is going to work is because 2 worked, and then I still had an even number left over. So 4 is going to work. Now, maybe I don't know off the top of my head. 4 times what? I don't know. 56 divided by 4 is 14. All right, well that, so there's no way I can plug a 4 and a 14 in. If I add them, I'll get like 18. If I make one of them negative, I can end up with like a 10 or a negative 10. Not going to work. It's not divisible by 5 because 56 does not end in 5 or 0. It's actually not divisible by 6 because for it to work with 6, it would have to work with 3, and it does not work with 6. Now, if you're not sure about that, you can go and put it in. You can do 56 divided by 6, and you're going to get a decimal. So 7. Okay, now you either know this or you don't know this, but if you don't, you do 56 divided by 7, and 7 does work. And I get 7 times 8. Now, once you hit the spot where your next number would be a repeat, you know you have all of them. So just like when we did the 12 and we did 1 times 12, 2 times 6, 3 times 4, okay? And we knew we got all of them. Then once you hit this, like, and you put the 8 here, and you're going to start repeating them. Okay, so most of the things that we factor are not going to have a huge list. I think 48 is probably the one that's going to have the most factors to it. Now, 7 and 8 actually will work to give me a negative 1 if I make the 8 negative and I make the 7 positive, because 7 minus 8 would give me negative 1, or 7x minus 8x gives me the negative 1x. Now you might be saying, well, does it matter which one goes where? Actually, it doesn't. And I did tinker around in Desmos, and I put it in both ways. And however that program is written, it's going to work either way. Now we should have what we need to finish the problem. So x squared has to factor into x times x. If I have 7x and is the area and the width is x, then this number out here must be 7. If you've got, you can do this a couple different ways. If you have negative 8x and you know the height is x, then that must be negative 8. And now we have our factors. Our factors are x plus 7 and multiplying that by x minus 8. And those are the two dimensions. That doesn't look really like an 8. Oh, sorry, didn't turn my pen back on. There we go. And there we go. Now that might seem like a long process, and it kind of is if you're new to the process. The more you do it, you will get very, very fast at this. But you have to do enough of the problems to get the practice to just kind of figure out like what's your pattern of your numbers. You will get better at it. Now you can also get your factors on the side here by looking for the greatest common factor, okay, which comes in handy with this. So if you were to look at x squared and minus 8x and say, what's the common factor? Well, this is x times x. This is negative 8 times x. X is the common factor. And you can do the same thing in this direction and this direction. So you can actually do the GCF and get your common factor that way. So what's the common factor between 7x and negative 56? Positive 7, factor it out. And negative 8 going up top. Okay, now if you need to hear that again, that took me about 8 minutes to go through that slide and explain the whole process. Rewind the video about 8 minutes so that you can see the explanation again. Don't just copy stuff into Desmos to get the homework grade, but not understand how to do it. So take that time. Okay, so now we're going to combine these skills. So what happens if you are asked to factor something like 5x squared minus 20x minus 105? So probably right off the bat, you're thinking, holy smokes, Ms. Taylor, 105? Ouch. Yes, exactly. Ouch. I don't want a number that's big. Here's the good news. Look for a GCF. There is not always a GCF, but if there is, we need to go and find it, okay? Now, good news with this problem is I have 5 times x squared, 20 ends in a 0, and 105 ends in a 5, which means that all of those have a 5 in common. So I'm going to see if I can find the common factor here. It's going to be 5 times x squared minus 5 times 4x. And then you might need to grab your calculator. Totally okay to grab your calculator. 105 divided by 5, and the other number is 21. Okay? So the common factor is 5. I'm going to take that 5 out. And remember, you're like, well, should it be a 5 or a negative 5? You want to keep that x squared positive. So I'm going to just take out the 5. Okay, generally you're safe if you just take out whatever's multiplying the x squared. Okay, so that's going to give us 5. And then we're going to be left with x squared minus 4x minus 21. And 21 is a lot less scary than 105. Okay, way less scary than 105. Now, what we can do is fill in the top left and the bottom right. So that 5 that we have right there, we're just going to sit on that for a little bit. It needs to be a part of our final answer, but we're just going to hold it off to the side for a moment. So there's my nice box, and I'm going to go ahead and fill in the top left and the bottom right. I'm going to have x squared and negative 21. Got that. The hardest part is figuring out what goes in those two diagonal boxes, but we have a method for doing that. Now we need to find two numbers that multiply to the bottom right, but add to that x term, which is negative 4. So the way we're going to do that is start looking at what are the numbers that multiply to give me 21, or in this case, negative 21, but we'll hold it at the 21 to keep it simple. Well, 1 times 21. Start with the 1 times 21. If you put in 1x and 21x, you are not going to get a negative 4. Okay, there's just no way to do it. If you add them, you'll get 22. If you make one of them negative, then you'll either get 20 or negative 20. Okay, but definitely not a negative 4. 21 is not divisible by 2 because it is not even. You may or may not know that it is divisible by 3, but if you don't, you'll grab your calculator and we'll do 3 times 7, and that I can get a negative 4 with if, when I plug it in, I make the 3 positive and the 7 negative. Negative 7x plus 3x will give me the negative 4x. Now, you can keep going. It's not divisible by 4 because it's not divisible by 2. It's not divisible by 5 because it doesn't end in 0 or 1. And it's not divisible by 6 because it's not divisible by 2. So if it's not divisible by 2, it's not divisible by any even number. And then the next number would be 7, but we already have the 7. So we've already covered all of that. Now we can go ahead and fill in the remaining areas and factor. So we have the remaining areas, and then let's go ahead and see our factors. This would factor into x times x. X going across the top means that this number over here would have to be a 3. And then you can do the last one using either of the boxes and then use the remaining box as a check. So if you had x and then the area is negative 7x, then this would have to be negative 7. And then use that last box as a check. Negative 7 times positive 3 is negative 21. So you know that it works. And then our last step is to list the factors. So the factors are x minus 7 times x plus 3, but don't forget the original factor of 5. Okay, that needs to be there too. So there's actually 3 things that are multiplied to give us 5x squared minus 20x minus 105. It is 5 times x minus 7 times x plus 3. There are 3 factors. 5, x minus 7, and x plus 3. Multiply, multiply. Factors are things that are multiplied. And now we're done with that problem. Took me about 5.5 minutes to do that problem because things do get faster the longer we go. But if you need to rewind it, you're going to rewind it for about 5 to 6 minutes and you can watch the whole demonstration again. All right, take a few minutes and try this one. As you work, I will circulate around for questions. Try to be sure you have something specific and not just a general statement about being confused, okay? Because that's not really a question if you just say, well, I don't get it or I'm confused. I don't know where to start in responding to that. So if you aren't sure what to look for or how to find it, ask. Be really specific. Say something like, I can't find the 2 numbers that add up to the ones that I'm looking for. Or I don't know how to factor the number that I have out here on the outside, okay? So here's the problem. What I want you to do is pause the video and work this out in your notebook, and then unpause the video and we will go over it. Now, in this case, in class, I may or may not go over it in class, but if you're just watching this from home, then you don't really know like what you need to. My phone is blowing up with a million text messages. So let's go ahead. Those are your statements, the things you need to do. Look for a GCF, fill in the top left and the lower right, then look for 2 numbers that will fill in the other areas and then factor from there. So go ahead, pause the video and pretend I'm circulating around. Do the problem out and then unpause it when you're ready to go over it. Okay, in this particular problem, there is no GCF. So I want you to remember that you want to look for one, but don't assume there always is one. The way you know right off the bat that there's no GCF is that the first term only has x's in it, there's no numbers, and the last term only has numbers, but no x's. So there's nothing that could be multiplied across all 3 of them. because if there was, either this would have a number or this would have an X, and there's nothing. But you do want to check. Then we're going to fill in our boxes. Okay, so we're going to fill in that top left is going to be X squared, and the bottom right is going to be the 28. Now what we need to do is we need to split up that 28 in a way that's going to add up to give us that 11, because we know that these two boxes are going to need to add up to give you 11x. So as you're factoring, you want to factor in some kind of way that has a system to it. So start with 1 times 28. That's not going to give you an 11. You could add them and get 29. You can make one of them negative and get a 27. Not going to get an 11. 28 is even, so you might grab your calculator and do 28 divided by 2. That's going to give you 2 times 14. So that also, you can't get an 11 with that, but you're getting close, okay? So if you add them, you'll get 16. If you make one of them negative, if you make like the 2 negative, you could get a 12, which is close to an 11, but not quite. Now let's do 3. 3 does not divide 28. If you're not sure, grab your calculator and do 28 divided by 3. It's not going to come out. It is divisible by 4 though. And the way I know is because when I divided it by 2, I still had an even number, which means you can divide by 2 again. And this would be 4 times 7, which will give us an 11, because 4 plus 7 would give us the 11. It's not divisible by 5 because it doesn't end in 0 or 5, and it's not divisible by 6 because it's not divisible by 3. And then 7, you've already got the 7, so you've got all of them. 4 and 7 are the 2 that will add up to give me the 11, which means I have 4x and 7x. Now it's totally okay if on yours you put the 4x here and the 7x here, okay? That's going to be fine. That's not going to affect your answer at all. All right, and now let's go ahead and get those factors. So this would have to be x times x. This would have to be a 7. This would have to be a 4. And then you can use that last one to check. 4 times 7 would give you the 28. And one thing that's great about this method is you can just double check all those boxes. X times x gives you x squared. X times 7 is 7x. X times 4 is 4x. And 4 times 7 is 28. And then if you add them up, x squared plus 7x plus 4x plus 28, 7x plus 4x is the 11x. So you can actually really check this as you're working. So this would be x plus 7 and x plus 4. So hopefully that's the answer that you got. That one I did in 5 minutes, so we are getting faster. And that's the goal. So some of you only need to do the homework because you need to just get faster at it. And there's the answer over there, but we already have the answer. So that's free in class. Okay, so your classwork and your homework, you are going to complete 3A as a classwork assignment and 4A as a homework assignment, and that's an in-class note there. I will release 4A with about 15 minutes left in the class period, okay? So I'll release that just so you have some time to work on it in class. If you're watching this from home, both of those assignments should be released for you, so you can go over to Desmos and just do both of them. And as with the others, it's going to self-check as you go. So you won't need to figure out if you're doing them right, because you get the big green check mark at the end if you are doing it correctly. So there's our lesson. Hopefully it wasn't too bad. It was 39 minutes to make up a 90-minute class period. Not bad. Hopefully you are watching it and you should be totally set to do your homework. Let me know if you have any questions.